Imagine trying to reassemble a shattered mirror. Not just piece it back together, but actually reverse the shattering itself. Watch the fragments fly backward through the air, reform into a perfect sheet of glass, and erase every crack as if the destruction never happened. Impossible, right? Now imagine you'd never even seen an intact mirror. You've only ever known the fragments, the shards, the broken pieces scattered across the floor. Could you figure out what it looked like whole? Could you reconstruct its original form just by studying the debris? This is exactly what cosmologists are trying to do with our universe. We exist 13.8 billion years after the greatest shattering event in history. Everything around us, every star, every galaxy, every atom in your body, is a fragment of that primordial explosion. And for decades, we thought we'd figured it out. We had a model, a timeline, an explanation for how it all began. Then, the James Webb Space Telescope looked at the edge of time itself. And what it saw broke everything we thought we knew. I'm here to tell you the story of how our understanding of the universe's beginning just shattered like that mirror, and why scientists are scrambling to put the pieces back together. Let's start with what we thought we knew. For nearly a century, the story went like this. 13.8 billion years ago, everything that exists, all of space, all of matter, all of energy, was compressed into a single point. A singularity of infinite density and infinite temperature. Then, it exploded. Not into space, but as space. The universe didn't expand into anything. It is the expansion itself. We call this the Big Bang. And the evidence for it seemed rock solid. In the 1920s, astronomer Edwin Hubble discovered that distant galaxies are moving away from us. The further away they are, the faster they're moving. The universe is expanding. If it's expanding now, it must have been smaller in the past. Rewind far enough, and you arrive at that singularity. The math checked out. The physics made sense. Then in 1964, two scientists accidentally discovered the cosmic microwave background, a faint glow of radiation filling all of space. This wasn't just any radiation. It was the afterglow of the Big Bang itself, the universe's baby photo. And when we measured it, the temperature, the distribution, the subtle variations, everything matched our predictions almost perfectly. We had cracked the code. We knew how old the universe was. We knew how it evolved. We knew what it was made of. Dark energy, 68%. Dark matter, 27%. Normal matter, 5%. The model was complete. Or so we thought. Then, in 2022, the James Webb Space Telescope opened its eyes. Webb isn't just another telescope. It's a time machine. Light takes time to travel. When you look at a star 1,000 light years away, you're seeing it as it was 1,000 years ago. The light hasn't reached you yet from its current state. You're literally looking into the past. Webb was designed to push this to the extreme, to see the most distant objects possible, to peer back to the universe's first moments. And when it did, scientists expected to see a sparsely populated proto-universe, a cosmic nursery, the first tiny galaxies just beginning to form. Small, dim, simple. That's what the models predicted. That's not what Webb saw. Instead, it found galaxies, hundreds of them, impossibly bright, impossibly massive, impossibly complex, and impossibly early. One galaxy, called JADES-GS-GS-Z14-0, formed just 290 million years after the Big Bang. In cosmic terms, that's an eye blink. And it wasn't some dim proto-galaxy struggling to ignite its first stars. It was huge, bright, fully formed, with 500 million solar masses already assembled. This shouldn't be possible. According to our models, galaxies need time to form. Gas clouds have to collapse, stars have to ignite, generations of stars have to live and die. This process takes billions of years. JADES-GS-GS-Z14-0 did it in under 300 million. It's like planting an acorn and watching it become a 100-foot oak tree in 6 months. The laws of physics don't allow it. And yet, there it is. But the problems didn't stop there. Webb started finding supermassive black holes. Black holes are the collapsed remnants of dead stars. When a massive enough star runs out of fuel, it implodes, crushing all its mass into an infinitely small point. Small black holes, stellar black holes, we understand. They form when stars die. But supermassive black holes are different. They're not just big, they're enormous, millions or billions of times the mass of our sun. And they sit at the centers of galaxies, including our own Milky Way. The question is, how did they get so big? Black holes grow by consuming matter, but there's a limit to how fast they can eat. It's called the Eddington limit. As a black hole feeds its accretion disk, the swirling matter spiraling into it heats up and emits radiation. This radiation pushes outward. Eventually, it pushes so hard that it blows away the very matter trying to fall in. The black hole hits a speed limit on its growth. Even if a black hole feeds continuously at maximum speed, it takes time to grow from stellar size to supermassive. Billions of years. But Webb found supermassive black holes that formed in just a few 100 million years. They shouldn't exist yet. And yet they do. Scientists started asking uncomfortable questions. Did supermassive black holes form differently than we thought? Did they skip the stellar phase entirely and form directly from collapsing gas clouds? Maybe, but we've never seen evidence of that happening. Or maybe, and this is the terrifying part, maybe our timeline is wrong. Maybe the universe is older than we think. Or maybe physics worked differently back then. Then there's the lithium problem. In the first few minutes after the Big Bang, the universe was a nuclear fusion reactor. Protons smashed together, forming the first elements: hydrogen, helium, and trace amounts of lithium. We can calculate exactly how much lithium should have formed, but when we look at the oldest stars in the universe, stars that formed from that primordial material, we find only 1/3 the lithium we expected. 2/3 of the universe's lithium is missing. Where did it go? No one knows. Some suggest it was destroyed in stars. Others think our models are wrong. But either way, it's another crack in the foundation. So where does this leave us? Are our models completely wrong? Do we need to throw out the Big Bang theory and start over? Not quite. The Big Bang model still explains too much to discard entirely. The cosmic microwave background, the abundance of hydrogen and helium, the expansion of the universe, those pieces still fit. But something is missing. Some scientists think dark matter behaves differently in the early universe than it does today. Others believe dark energy, the mysterious force accelerating the universe's expansion, was stronger back then. Still others think we're witnessing evidence of primordial black holes that formed directly from the Big Bang, bypassing stars entirely. Or maybe the universe didn't start with a singularity at all. Stephen Hawking himself changed his mind about that later in life. He suggested that quantum effects might eliminate the need for a singularity altogether. The truth is, we don't know. And that's what makes this so exciting. Every time we think we've figured out the universe, it surprises us. Every new telescope reveals something we didn't expect. Every observation challenges our assumptions. The James Webb Space Telescope isn't showing us a universe that fits neatly into our models. It's showing us a universe that's stranger, more complex, and more beautiful than we imagined. And somewhere in that strangeness is the truth, the real story of how everything began. We're not there yet, but we're getting closer, one impossible galaxy at a time. The universe's beginning is still a mystery, but it's a mystery we're going to solve, because some questions are too important to leave unanswered. And the answer to our ultimate origins is waiting out there, hidden in the light from the edge of time. We just have to keep looking. If this story fascinated you, there's more cosmic mystery waiting. Subscribe to explore the discoveries that are rewriting everything we know. What do you think happened at the beginning? Let me know in the comments. Until next time, keep looking up. The universe is full of impossible things.